You know that autocomplete on your phone where you type how are and it just pops up with you? Well, an LLM is basically that same idea, but scaled up to a level that is just hard to even imagine. But here's the thing, it's not magic. And in this explainer, we're going to break down how it really works. And it all comes down to what happened when it was being trained, right? So the simple prediction, this is the core concept. This is the engine behind every chatbot, every AI writer you've ever used. The only real difference, instead of just learning from your text messages, it learned from a massive, massive chunk of the internet. We're talking trillions of words, so LLM. It stands for large language model, and honestly, every single one of those words is important. Large means it has billions of tiny internal settings, all of which were tweaked and adjusted from reading all that text. Language is pretty straightforward. It reads text and it produces text. But model, that's the key. It is a math system. It learned from data. It is not a person. There's no consciousness in there, no secret mind. Okay, so here's the first thing that most people don't realize. And it's kind of weird. To really get what an LLM is doing, you have to understand that it does not see language the way you and I do. Not even close. This right here is the fundamental difference. We see words. The model, on the other hand, sees tokens. And tokens are basically just word fragments. So a simple word like that might be one token, but a more complex word like understanding could be split into two tokens, like under and standing. It's just a totally different way of chopping up language. And it actually goes one step further than that. The model doesn't even really see the tokens themselves. It sees numbers. Every single token has its own unique ID number. So a simple question like, what is AI, just becomes a sequence of numbers. And from that point on, the whole entire process is just math. And that's it. That's the whole game. It looks at that string of numbers and it predicts what the next most likely number should be. Then it takes that new slightly longer sequence and it predicts the next number again. It does this over and over, one token at a time. It is, and it has always been, just extremely advanced autocomplete. So you're probably wondering if it's just guessing the next word fragment. How on earth does it manage to write entire essays that actually make sense? Well, the answer to that is in how it was trained. And this is where things get really, really interesting. This is probably the biggest misconception out there. The model did not memorize the internet. It didn't store it like a hard drive. It compressed it. The best way to think about it is like a JPEG photo. You see the whole picture, but if you zoom way, way in, all the fine details start to get blurry. The model stores the general patterns from all the text it read, not the perfect pixel for pixel facts. And just like a blurry JPEG has what they call artifacts, those weird blocky bits, the model's knowledge has artifacts too. This is one of the main reasons it hallucinates or just plain makes things up. It's not trying to lie to you, it's just trying to reconstruct information from a compressed version where some of the original sharp detail got lost. Okay? So the compression artifacts explain the mistakes, but that doesn't really explain the confidence, does it? Why will it invent a scientific study or a historical event with complete and utter conviction? Well, the reason for that goes even deeper into how it was trained. During its training, you can think of the model as basically taking a giant test, like a multiple choice exam. A correct answer got at points, but saying, I don't know, got at 0 points. And leaving a question blank, that was actively penalized. So what does a system like that learn? It learns one simple rule. Guessing is always the best strategy. The model was trained over and over again that providing a confident sounding plausible answer is always a safer bet than admitting it's not sure. That behavior is baked right into its DNA. So when an LLM makes up a court case that never happened or a book that doesn't exist, it's not broken. It's not trying to trick you. It is doing exactly what it was rewarded for doing millions of times during its training, produce a plausible sounding answer, whether or not that answer is actually true. This brings us to the part that I think people get wrong more than anything else. We tend to assume there's some kind of thinking process happening behind the scenes. But what's really going on inside the model when it generates a response is actually much simpler and, in a way, much weirder. So get this. This is fascinating. The model spends the exact same amount of computer power, the same amount of effort, predicting a simple word like the, as it does, predicting the answer to a really complex math problem. Every single token just gets one pass through the whole system. It doesn't slow down to think harder. It doesn't have different gears, which of course leads to a great question. If it's not actually thinking harder, then why does prompting it with things like think step by step or show your reasoning actually lead to better answers for hard problems? It works because you're essentially giving it a bigger workspace. When it writes out a step of its reasoning, that step becomes a new set of tokens. And those new tokens are then fed back into the system as context for predicting the next step. It's not thinking harder. It's more like it's thinking aloud. And that growing trail of thought helps it get to a better final answer. Now, this workspace isn't infinite. It has a limit. And that limit is called the context window. The absolute best analogy for this is a desk. You can only fit so many papers on it at one time. Once your conversation gets too long, the earliest parts of it literally fall off the desk. The model completely forgets they ever happened, which is why it can sometimes seem to lose the plot in a long chat. Okay, so let's try to put all of this together into a simple, practical way to think about these tools every time you use them. It's really about seeing the AI for what it is, not what we imagine it to be. At the end of the day, an LLM is a mirror. It reflects the quality of what you give it. If you give it a vague, low-effort prompt with no context, you're going to get a vague, unhelpful output right back at you. But if you provide specific details, clear instructions, and good examples, well, the reflection you get back can be incredibly useful. And look, if you remember only one single thing from this entire explainer, please make it this. Because of the way it was trained, it never ever learned to say, I don't know. It will always give you an answer. And that means the final responsibility for checking the facts is always on you. So, what's your new role in all of this? Think of it this way. Use the AI as a super fast, super confident partner to create a first draft. It's seen more text and synthesized more patterns than any person ever could. But you, the human, you are the editor. You have the judgment. You understand the real world context. And you do the fact checking. You verify everything that actually matters. Understanding this whole process from the tokens to the training to the incentives, that's really the key to using these tools well. It's not magic, it's just a mechanism. So the real question to walk away with is, now that you can see the mirror for what it is, how are you going to change the reflection that you create with it? Thank you.